Right, this is an MS2. Just go back over what we've done. Cold advance, so you can see add a little bit of advance, do it when it's cold. Manifold air temperature timing retard, so you can retard the ignition depending on air temperature, as we discussed in MS3. Correction table, manifold air temperature correction table. There's none in this one, in this particular tune file, but depending on how you get on, you may need to adjust that. Correction value 100%, and knock sensor settings as we've been over earlier. Safe mode or aggressive. This does no analog input or built-in system. This is just an on or an off, a low or high system. These ones have the same as the knock detection systems I build, so they're okay to be used with these. Depending on which pin is connected to, JS4, JS5. Indicated by low, 99% is going to be low. Pull up, so make sure the pull up is on up, and then how many knock counts you have before it starts pulling knock out. Ignore above, so if you want to only do it up to into boost, then whatever you wanted to do here. Window for RPM low and high, so if you know you're getting a lot of noise high RPM but no knock, then you can just set this window up so as it doesn't do it above a certain RPM. Maximum retard, this is how much of that pull out at the maximum, how often it checks it. Step size, it'll be 3 steps every 0.2 of a second if it sees knock, until it stops there knock, and then once it stops there knock, after 2 seconds on this one, it'll advance 1 degree at a time back to the main map again. But if you're in safe mode, then it would add 1 degree advance until it got to 3 degrees away from the main map. Overrun fuel settings, I think I've covered that already. May not. Yeah, I think I have done in. I think I have covered that already in MS3. That's the same. So that's on. So you can set up all your overrun exactly the same as MS3. Okay, we'll just cover table switching. This is switchable maps. We put this on. We've got hardware, which is an external input that you'd have to have built with the ECU. When the ECU is built, this would have to be added. So you'd have an output that could be switched on. So it'd be local. There's only 2 possibilities. There's only one local setting. That's local to the ECU, which is what most of you would have. Remote means if you're using the CAN bus in MS2 or MS3, but not many people. If you knew what if you'd added CAN yourself, then you'd know what you were doing here. So it's going to be local. There's only one input for it, so it knows straight away that which one it is. So that switches fuel tables on between different fuel tables. So now we should have. If I close that. We should have another fuel table opened up. Fuel table VE3. So when the input comes on, it'll switch to VE3, VE table 3. When it goes off, it switches back to VE table 1. So there's your 2 fuel tables. Without the switch on, that'll be running from 1. With the switch on, it'll be running from 3. And the same with the spark. Where'd it go? Switch table control. Same as spark table, you can switch between the spark tables, 2 spark tables if you want to. Or you can have it so as it switches at certain RPM, throttle position or kPa. So you can have it, if you're clever, you could have it so as it, say for instance up to 100 kPa. So here 100 kPa, you had 1 spark fuel map then used up to 100. And then after 100 kPa, what you could do is you could start here at 100 and work all the way up to wherever you want to. If you've gone up to 250 for instance, so you could have another table, so you'd end up with a 16 by 32 high table, so 16 across there and 32 up there. It'd actually be 31 because two of them would, the bottom two would need to share the same, so that'd have to be 100 the same, and them values there would have to be exactly the same as the upper values here. So you'd have to copy and paste this, copy, paste that in there. Then when it switched between them, you didn't lose anything, so you didn't, because it need to have 100 base in here in order when it switched to 100, so the fueling carried on. And then up here you could just do whatever you wanted with this little lot here above 100. Equally, if you wanted to do it on RPM, you could go across here to say 4,000, 5,000, and then have the other table, the second table, the table 3, from 5,000 onwards to 10,000 or whatever you wanted to. So you could end up with quite a long or quite a tall table. To be honest with you though, if you can't tune it within these tables, then you've got a very weird engine, because I've not ever come across that needed. But some people may want to do it. And you can also do it on throttle position as well, or KPA, so if you're in alpha N you could run it on throttle position. We'll turn that back off again. So basically fuel table switching in MS2 is between VE table 1 and 3, spark table 1 and 3. On MS3 however, this just ups the game a little bit more, in that, if I can find it, fuel table switching. Here you can switch between everything and anything. So in my case I'm switching fuel table with the hardware. My input is CAN input 1, so when CAN input 1 comes on, I'm switching my spark table and my fuel table between them two there, that one and that one. And the reason I'm doing that is because if I go start getting any pink, or I go lean in boost, I've added a load of fuel up the top here to one table, so I can just switch it on and know that I'm adding a bit too much fuel. And I've also retarded the ignition in boost. I've never had to do it, but I had the inputs there, so I thought I'd use them. But you can also switch between required fuel values, so you can alter a different required fuel. So this is handy if you're using LPG. So if you're using LPG and you want to have different spark maps, different fuel tables, and you're switching between different injector systems, then your required fuel value would need to change. So you can switch that as well if you want to. You can switch different AFR tables, so you can switch in between one AFR table or another. You can switch in an alternative AFR target. So generally the Stoich is 14.7 for fuel. If you're using LPG it may be different, or say another different sort of fuels may have a different type, a different target as far as Stoich is concerned. So it may run most efficiently at say 15.5, so you could switch the Stoich point if you wanted to. And you've also got dual fuel as well, which brings in all sorts of modes of on the system, so you can alternate fuel tables, spark tables, all sorts of things with different fuels. I've never had the need to use this so far, so I'll leave that alone. But the facilities there, it really is phenomenal what you can do with it. Absolutely phenomenal. But that's the basics anyway, switching fuel tables. So fuel and spark tables, and your spark tables, table 3 and table 1. So that's the standard spark table. As you can see, I'm running sort of 19 degrees in boost as I start to go into boost. If I look at spark table 3, I'm running at 16 degrees as I go into boost. Just in case anything goes wrong, I've got a little switch I can switch over and retard the ignition, add some fuel, because you can just not put your foot down in the first place, and everything will be okay. But ideally this is for LPG, so you switch between an LPG and a fuel setup, so as you can map both systems. but there's all sorts of things you can use it for if you really want to. Back to MS3, or where we were anyhow. Exhaust gas temperature settings. You can have a load of exhaust gas temperature probes connected to, as long as you've got the inputs. So if you had a CAN device like I've got, I can add 8. Well, I've got up to 8 exhaust gas temperature probes that I can switch in, and they'll be data logged. Or you can, if you really want to, have them cut the fuel, do all sorts of things if they get too hot. But I tend to just use them for monitoring, so I look through the data logs, look at all 8, and try and tune each cylinder for to get the same exhaust gas temperature on each cylinder. Generic sensors. This is, for instance, I've got a air temperature sensor that reads the air temperature after the supercharger but before the intercooler. So mine's on ADC input 1 of the CAN input device. That's a GM sensor, so it's GM calibrated, but you could use the same as the manifold air pressure. If you want to have a sensor that's manifold air pressure or coolant sensor, or you can have all sorts of sensors connected if you wanted to. That's only monitored. That's not actually, doesn't do anything, and that is the reading there. That value there is my one, and I can just look at it through the data logs. Accelerometer. This is if you have got a G-force meter connected on the CAN bus, or anywhere really. You can have a G-force meter connected, and you just set up what the values are. Again, it's just purely for monitoring. Traction control. I've not played with this yet, but I do intend on doing some of this over winter. So you can have allow a certain amount of slip or perfect run. Enable inputs, you can turn it on and off if you want to. Minimum throttle position for it to cut in, minimum map. You would need vehicle speed sensors connected to do that, which aren't cheap, and you'd need an awful lot of analog inputs. So ideally you'd need to add at least an MS3X card, or the better still would be the CAN bus system, the I/O extender for the CAN bus, because that actually has analog inputs, VR sensors all built into it. It's a bit expensive though. Probably not expensive as proper traction control or an external, a separate traction control. So just depends how much work you want to put into it. But you can then have all sorts of settings that you can mess about with for control. So you can cut the spark if you want to stop nitrous working, add fuel to stop traction, or gain traction rather, retard ignition to reduce engine power, all sorts of things. That's very intricate and needs a little bit of setting up. But anti-lag, depending on what input you're going to use. Anti-lag, this is for turbos, very very harsh on your turbo. If you know what it is, then you know how to set it up. Personally, I don't think that should be used too much, but certainly on road going cars. Nitrous, if you've got separate outputs for nitrous, we can do this on MS2 as well. I think it's a little bit more basic on MS2. Where are we? Nitrous system. So you can turn the nitrous on. There's 2 banks of nitrous you can switch on and off on the MS2, and looks like there's 2 on MS3 as well. So back to MS2, you can turn it on when above a certain RPM and the coolant's above certain temperature and the throttle position's above certain. The input, depending on that, would be local. Unless you're using a CAN bus, then it would be remote. So local input, and then here, depending on which input you're using, which input you've wired it to, when the input come on and all these parameters are enabled, then the output, it would be local, or if you're using a CAN bus, would be remote, and then this would be either IAC 1 and 2 or the fast idle and D15 output. So you're going to use IAC 1 and 2, chances are, for that. And then you can add fuel if you've got big enough injectors whilst just doing it. Maximum RPM when you want the system shut down, and additional fuel pots with that max. Oh, so this is minimum RPM. So say for instance you had this is a scaling between when it starts. So if it turned on at 1000 RPM, then you may only want to add 5 milliseconds of fuel. And then when it gets to maximum RPM, you want to be adding 25 milliseconds of fuel. So that'll scale between 5 and 25 milliseconds of fuel, depending on the engine's RPM. That's so as you offset, that's added, so it's added fuel. So that's so as you, if you add, say, 50 brake horsepower short of nitrous, then you know you may need, I don't know, for instance, 5 milliseconds of fuel for that. Then you can add that 5 milliseconds of fuel there, and then the maximum here. You can also have dual stage somewhere. There is a way of having two, or nitrous system 2, so you can have it switching in 2 stages. Then you end up with this page here, which is the same as that one. So you have 2 outputs. One comes on to start with, then the next one comes on. So you have 2 stages of nitrous switched in, and that's the same as MS3. But you've got a progressive mode, so you can control the solenoid frequency, solenoid valve, and adjust the frequency. You can adjust the AFR safety system, whether it's still on or not, and that's a little bit more controllable. But it's very similar, but it's just, again, it's in more depth because the ECU is capable of so much more. So them functions have been added to. So and here you've got targets tables of duty cycle versus RPM for nitrous 1 and 2, amount of fuel added, so you can scale the fuel better over the RPM that's added. Obviously your injectors need to be capable of adding that extra fuel though. So that's that. Water injection. This is a table, a pulse width modulation table that you can use for water injection. Basically, switch it on, you've got a pump output if you want to turn the pump on at a certain position. Then you've got a valve option, so you can also switch a valve on and off to pulse the water in and out. So you basically switch pump on. If you've got a valve, then you switch the valve on as well. So the pump will come on nitrous output 1. The valves be controlled in this case by injector bank 1 output, because I'm using the injectors on the MS3 X board. So injector bank 1 would be the main injector drivers that I'm not using. These are the ones I am using. And then you can tell it when to come on, so above 55% throttle, above 1500 RPM, when the kPa is above 85 and the manifold air temperature above 42. So if the manifold air temperature isn't hot enough, then don't bother squirting any water in. If it is, when it gets to 42, I'm going to start adding a little bit of water. And then you can alter the amount of water you squirt in, or the pulse width to the valve here. So 100 would be 100%, so it'll be on all the while. 80 would be 80%, so on 80% of the time, and so on and so forth. So valve style, if you put in slow, you can adjust the frequency of the valve. So if you're not sure what sort of valve it is, you can adjust the frequency. 9 times out of 10, if you're using an Aquamist valve, then you'll be in fast mode, valve style fast mode. But if you know the frequency of the valve you're using, then you just select the valve in slow mode. So and then if you want to use maximum AFR shutdown, you can turn that off, or you can have it switchable so it's on only at certain, when you've put an input in. But your AFR table is going to go leery, your AFR is going to go mad when you start putting water in. So generally tend to have tuned it all okay without water, then add the water in and ignore the AFR sensor, because water will increase the oxygen in the air, in the mixture, and make it look as if it's lean. So so something to bear in mind. So this, I'm going to start playing with this on mine because I want to add a little bit of water injection just to keep the temperatures reasonable in the when it gets hot, if we ever do get any summer this year. Then you've got generic pulse width outputs, which you can use for anything you like. So this is the output pin I'd use, so depending on how you'd wired it in, on and off, so it's on at a certain duty and off at a certain duty, or variable, which it then uses this table, pulse width modulation table. So this would be the engine load, so your engine load, so and the engine speed. So this at the minute would give 32% duty cycle out all the while. You can change the map, so throttle position up and down, or whatever you want, coolant based. So there's lots and lots of outputs here that you can use for various functions. For cooling fan, for instance, you could use it for a variable cooling fan, so the pulse width increased as the coolant increases. So as the cooling fan was on for longer, or spinning faster effectively as the coolant increases, that sort of thing. There's the possibilities are endless really, and you've got up to 2, 4, 6 of those outputs that you can program on MS3. That's only MS3, they're not available on MS2. Same as water injection. I don't think water injection's on MS2. It was on MS1, but it's not on MS2. I think that's it. That'll do for now. I think the next stage is we need to discuss our tuning, so we'll leave that for now.